I'm Raphael Jabba, and this is tutorial 6.7 for my electrical engineering class. What I have here is a motor connected to a SparkFun breakout board on top of my Arduino Uno. I have a switch to select between 3.3 volt power and 5 volt power, as well as two push buttons for speeding up and slowing down the motor so I have finer control. The buttons also turn on an LED when they're pressed. There's also another single pole double throw switch that will break the connection for the motor so that it can be shut off completely without unplugging the board. The best part about this switch is that it required no code to work. The switch just reroutes the connection to an unconnected pin so that the motor does not move. You can also see as I press on the green button, the green LED lights up and the motor will speed up. Opposite happens when I hit the yellow button, and now the yellow LED turns on to show that slowing down, just like a traffic stop or a traffic light. Now if I hit this switch, I can make the motor even faster by switching it to 5 volt power instead of 3.3 volts, which will just increase its maximum speed. Since I had to use a breakout board instead of using a simple transistor and a flyback diode, I had changed the code slightly. This board is the SparkFun TB6612FNG, and I'm using the pins it provides for direction input, PWM input, and then the motor outputs, as well as a standby mode, but we won't be using that for this because of the on-off switch. It just stops the motor instead of using the on-off switch. But first in the code, I will declare the pin numbers in two variables. One of the variables is for direction, and the other variable, speed x, is to change the speed. This value will be PWM, so it can go from 0 to 255. The pins, PMWA, that will be used to send the speed value, and these two, 9 and 8, will be used for direction, but they have no use for this current project. Now going down to the setup section, you can see that I have made everything output except for two, which are input pull-up. These are used for the receiving signals from the push buttons so that they'll be able to change the speed of the motor. I also put the serial begin code so that the serial monitor down here will be able to work. In the loop section of the code, the first thing that you'll see is the move command. This will use the move function down here, and I will get to that in a second. You can see that it has three different variables right here, but we only need two, or actually only this one for what we're doing now, which is the speed. Next is the if statements for the push buttons. If the pin right here, the digital read, reads a low, that means that the button was pressed, and this will cause it to increment the speed by one value, so that if it's 1, it'll go up to 2, and it'll keep going all the way to 255, but it'll also keep going after that. And this delay here is to change how fast the value is incremented. If I made this number here, the 10, if I made that 50, the number would go up slower because of the higher delay. If I made it 1, it would go up much faster, and it'd be hard to change speed values. The same thing is for here, but it's for the other button, so that instead of making it higher, but you can see with the plus plus, it makes it lower because of the double negative sign, and that just decrements it by one value. Same delay, same everything else. You can also see that I have the print ln speed x, which will just print the value of the speed x variable down to this serial monitor down here. Now I will press one of the buttons on my board, and it should cause that to go up. If I go back down the other way, now it's tapping it, and it updates the value only while I'm pressing it, because it's only in this if statement, not anywhere else. And also you can see that the value it doesn't keep going. Normally, if I didn't have these two statements here, the value would just keep going past 256 and would cause issues with the motor. And that's something called overflow, where instead of going to 257, it goes all the way back down to 0. So if I was telling the motor to speed up, it would keep going and then instantly go back to 0 and just continue the cycle. Same thing other way around as well. The last part of the code is the area that defines the void move function. First, it will just disable the standby so that let the motor move. Then it declares which direction. But these two things are not important for the current project because we only want to change the motor's speed. Because if I want to shut off the motor, I can just use the switch I put on the board. Same thing for this, we do not need to change the direction. But right here is the important area. This command right here, it will write the analog value or the PWM value of the variable to that pin, or pin PMWA, which if we scroll back up is pin number 11. And that is connected to the red breakout board or the motor driver, which is connected to the motor. And so depending on this value, that will change the speed of the motor. Lastly, we have the schematic for this project. This was made using a new program called KiCad. It's completely free, but I've never used it, so there may be some mistakes. But it has everything from the motor driver, the TB6612F&G, to the exact same Arduino that I'm using. So it should be compatible with pretty much every project that we do. But you can see here that the dual, or the push buttons, are connected to pins 2, pin 7, and then of course also connected to ground. Then you have pins 10 and 12 connected to the motor driver, or that one, with the speed and the standby, which is also then connected to the motor with this on-off switch, which is being supplied voltage by this switch for either 3.3 volt or 5 volt. When you look at it this way, it just seems like a much simpler circuit than looking at the thing in real life.